I think for most classes we did the top of page 2 on the board together, but just in case you weren't here that day, or if you just need another explanation of it, I'm going to record a video so that you can get that. So I already have this one filled out. The main thing that you need to remember is that the number of electrons that will be described in your electron configuration will match the atomic number for that element. So I'm going to use my little baby periodic table here. For sulfur, since that's atomic number 16, that means that my electron configuration needs to have 16 electrons. So that'll be 2 plus 2 plus 6 will give me 4, plus 2 is 12, plus 4 is another 16. So we have 16 electrons described here. And then our orbital diagram, I think we only spent a very short amount of time on this. So as a reminder, the number of orbitals that each sublevel has at any given energy level is going to be half of the number of electrons. So for example, if you are in the S sublevel, since any given energy level in the S sublevel has 2 electrons, the S sublevel is going to have 1 orbital, which just corresponds to 1 line. The P sublevel has 1, 2, 3, 4, 5, 6 orbitals, or sorry, 6 electrons. So half of that would give you 3 orbitals. So P has 3 orbitals. D has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 electrons, which would correspond to 5 orbitals. And F has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 electrons, so 7 orbitals. On your little periodic table, the small one that I had you guys color in addition to the front page of your notes, if you are confused on any part of this, this might be a really smart thing to write on there for yourself. I would maybe even go ahead and show it as S, P, D, and F with the number of lines to represent the orbitals. So S has just 1 line, P will have 3 lines, D will have 5, 1, 2, 3, 4, 5, and F will have 7. I don't have space there, but 7. So when the question asks, so something like this, how many orbitals contain electrons, what you're counting is the number of lines. So orbitals are represented as lines. And the reason that the number of orbitals is always half of the number of electrons is because we can fit 2 electrons in every orbital. So if I do my orbital diagram for sulfur, I'm just following along my electron configuration and placing the electrons where they belong. So, for example, in my orbital diagram here, I'm starting with 1s. Since it is an S sublevel, it's going to have 1 line. So 1s is going to have just a single line. After 1s, I move on to 2s. Since it's still an S sublevel, even though the number changed to 2, it's still S. S just has 1 line, so I'm going to do 2s. Then I have 2p. Even though that number says 2, it's a p sublevel, so that's what I'm looking at for the number of orbitals. I need how many lines for a p sublevel? I see some 3s standing up. Okay, so 2p, 1, 2, 3. And then I go to 3s. Since it's S, how many lines do I need? 1. And then 3p. So 3p, 1, 2, 3. So it's only the letter that dictates how many orbitals or how many lines you're drawing for your orbital diagram. In 1s, I have 2 electrons. So to place those 2 electrons, they have to have opposite spins, and we represent that as an arrow. In 2s, I also have 2 electrons. Again, they have to have opposite spins, so I represent it as an arrow. For 2p, that's where we have to remember Hund's rule, or the Pauli exclusion principle. So both of those are going to come into play here. Where if I have 6 electrons and I have 3 lines, the way that I fill them in is that they each have to have opposite spin, and then Hund's rule is what tells us that each one is going to have 1 electron with the same spin before any one has a second electron at all. So when I fill up 2p, I'm going to take up, 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 and then the other 3 to meet my 6 is going to go down, down, down. When it's full, it technically does not matter if you go up, 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 down, down, down. It's when it's not full, so really the last energy level sublevel is going to be where that matters. And then 3s2, same thing. We have 1 up and 1 down. And then 3p, I have 4 electrons in 3p. So this is where Hund's rule really comes into play. You have to go up, 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 so that each orbital has 1 electron with the same spin before any orbital gets a second electron. And we're not going to put second electrons on those because my 3p already has 4 electrons. Then we'll usually have follow-up questions for each of our orbital diagrams. Question A says, how many EL, that stands for energy levels, in an atom of sulfur have electrons? So let me just go through the energy levels. Does energy level 1 have electrons? Yes. Energy level 2 also has electrons, so that's 2. Energy level 3 also has electrons, so that's 3. There is no energy level 4 for sulfur, so we're just stopping at 3. How many orbitals contain electrons? This means that I'm counting the lines. So this is going to be 1, 2, 3, 4, 5, 6, 7, 8, 9. You gotta get 1, 2, 3, 4, 5, 6, 7, 8, 9. Yep. And then how many electrons are unpaired? Unpaired means just a single electron by itself. That would be 2 electrons that are unpaired. And how many electrons are in the second energy level? So another way to say this would be the n equals 2 energy level. So I look at anything with a big 2 in front. So I have 1, 2, 3, 4, 5, 6, 7, 8. I can also get that from the electron configuration where I have these 2 plus these 6. Those are both of the things, 2's in front of them. Both of them will give me the same answer of 8 electrons. All right, number 2 is talking about iron, which is Fe on our periodic table. So it has 26 electrons. So we're going to start this one from the beginning and write out our electron configuration. Every single time we do the electron configuration, we're starting at our lowest energy level sublevel. So I'm starting at energy level 1 in sublevel S, since that's all there is. So I'm going to start with 1s. And in 1s, to get to iron, I need to go through all of the boxes that come before it. So since iron is number 26, I need to pass through 25 boxes before I get there, and I'm just going in order of atomic number. So 1s, the total number of electrons that will be in 1s will be 2 electrons. After 1s, if we read straight across, we get to 2s, and the total number of electrons there will also be 2, so 2s, 2. After 2s, we hit 2p. The total number of electrons that will be in 2p, if it's full, are 1, 2, 3, 4, 5, 6. After 2p, we go down to the next line, which is 3s. There will be 2 electrons there. After 3s, remember to keep reading straight across. We aren't going to go down to 3d. We just keep going straight across to 3p. So 3p, and for that to be full, it would be 6. After 3p, we go to 4s. It will be full with 2 electrons. And then finally, we'll be in 3d with 1, 2, 3, 4, 5, 6 electrons. So the only sublevel that's not full is this last one, 3d6, because if I wrote 3d10, that would put me at this box, but I need to stop when I get to the element that I'm looking for. So that is how we'll write all of our electron configurations. And then the orbital diagram for iron, we're going to do it the same way that we did up here, where the only thing that dictates the number of lines or orbitals that you're drawing is the letter. So for 1s, I have 1 line because every s sublevel just has 1 line. 2s, I'm also going to have 1 line. 2p has 3. 3s has 1. 3p has 3. 4s has 2. Or sorry, 4s has 1. So 4 has 2 there. And then 3d has, how many lines would I draw for 3d? 1, 2, 3, 4, 5. So 1s, 2s, 2p, 3s, 3p, 4s, 3d. And then we go through, each of them will be full. Remember that when we do this last one, so each of these lines, I'm going to kind of skip them just to make this go a little bit faster. For 3d, I have 6 total electrons but 5 lines. So I would follow Hund's rule where each one gets 1, that's 1, 2, 3, 4, 5, before any of my orbitals get a second arrow or second electron with an opposite spin. So that's what that would look like. All right, letter A says how many energy levels in an atom of iron contain electrons? The number of energy levels, I have energy level 1, energy level 2, energy level 3, and energy level 4. So that'll be all 4. How many orbitals contain electrons? Assuming that I actually took the time to fill all of these in, would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. How many half-full orbitals are there? We have 1, 2, 3, 4. And how many full orbitals? That would be 11. So counting all of these plus that one, 11. And then how many electrons in the third energy level? I have 2 plus 6 is 8, plus another 6 is 14. Which should be the same because this would have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. And I'll stop that there.